Number 2 says simplify the exponents below. And we've got 6 to the 12th power times 10 to the 5th over 20 to the 5th power. Remember that in simplest exponential form, the following things are true. All of the bases are prime. All the bases are only written once. All of the powers are positive, and there are no parentheses. So let's go ahead and break this down. Let's think about the factors of each of these factors, right? So in my numerator, I've got 6 to the 12th, and I know that 6 is 2 times 3. So really, I'm thinking of 2 times 3 to the 12th power. And then 10, hey, that's 2 times 5. So instead of 10 to the 5th power, I'll think of 2 times 5 to the 5th power. 20, well, that's 4 times 5. But a better way of saying that would be 2 times 2 times 5, right? Because I want to break these down into prime factors. That's my whole goal with simplifying this. So 2 times 2 times 5 will give me 20, and that's raised to the 5th power as well. Let's simplify this even further. So I'm taking 2 times 3 to the 12th power times 2 times 5 to the 5th power times 2 times 2 times 5, all to the 5th power. All right. Let's use our rules for raising a power to a power, and also use our rules. Actually, let's use the rules for power to a power first. Let's, instead of 2 times 2 times 5, change that denominator so that it says 2 squared times 5, right? Because that means the same thing as 2 times 2 times 5. All right. We need to remember when we're dealing with parentheses that we distribute the power to all of the factors in the parentheses. So when I rewrite this exponent, this will become, instead of 2 times 3 all to the 12th power, 2 to the 12th power times 3 to the 12th power. And then instead of 2 times 5 in parentheses to the 5th power, we're taking 2 to the 5th power times 5 to the 5th power. My denominator, I've got 2 squared to the 5th power. Well, that'll become 2 to the 2 times 5, or in other words, 2 to the 10th power. And I'm taking that times 5 to the 5th power. All right, now that I've got my exponents all broken up over prime factors, what I need to do is take a look at my like factors. So let's look at the numerator first and then the denominator. I've got a base of 2 in the numerator with 2 to the 12th power and also 2 to the 5th power. So if I were to rewrite that as one term using my rule for multiplying exponents, that would become 2 to the 17th power. There's only one 3 term right now, so let's leave it as times 3 to the 12th power. And then there's also only one 5 term in the numerator. That's 5 to the 5th power. We'll leave it there. And then my denominator is already as simple as it can get, so let's just copy it and keep it the exact same way it is. All right, so what I've done so far is I've started with composite bases. I've broken them down into prime bases, and then I've combined those prime bases in each my numerator and denominator so that each base only appears once in the numerator and once in the denominator. Now it's time to cancel out any common factors. So let's go ahead and do that. Using my rules for dividing exponents, I can simplify. I know that in my numerator, I'll end up with 2 to the 7th power because I've got 2 to the 17th divided by 2 to the 10th. Then I also have that 3 to the 12th power. There's nothing to cancel out with. So that'll be times 3 to the 12th power. And then I have times 5 to the 5th power, but that's canceled out with this 5 to the 5th power in the denominator, so that equals 1. So that all that's left in the denominator is a factor of 1. So when I simplify this problem as completely as I can simplify it, I end up with just 2 to the 7th power times 3 to the 12th power.